Alright, we are in section 6.3 where here we are perform function operations and compositions. Basically, operations on functions is we're letting f and g being two separate functions, and then here in our examples we're giving it a new function h, but we can define it by performing some of the basic operations for f and g. So here in the table, I have h of x equaling f of x plus g of x. Well, in our example, here I have f of x equaling 9x, and then my g of x is equaling negative 4x plus 3. So basically what we're doing is we're substituting in what f of x and g of x equals, and then we're either in adding, subtracting, multiplying, or dividing, and then we're combining the like terms that'll help us solve our problem. So for addition, if we have h of x equaling f of x plus g of x, so then we're just taking 9x here, which essentially is f of x, plus, and in parentheses, negative x plus 3. If you get rid of that parentheses, it's just 9x minus 4x plus 3, and then we are performing like terms here, which then gives us our answer of 5x plus 3. Same thing goes for subtraction. Here it shows, again, for multiplication and also for division. So if I were to use this for addition and subtraction, I'm going to use the same methods that we're going to use from the top. So here I'm letting f of x equaling 8x to the 1/2 power minus 5x to the 1/3 power. G of x equals negative 3x to the 1/3 plus 11x to the 1/2. So here for A, I have g of x plus f of x. So g of x here is, I'm just going to put in parentheses, negative 3x to the 1/3 plus 11x to the 1/2 plus f of x, which is 8x to the 1/2 minus 5x to the 1/3. Get them out of the parentheses. I'm just going to say negative 3x to the 1/3 plus 11x to the 1/2. It stays the same. And because it is addition, my second parentheses will stay the same too with their sign. So it's still positive x to the 1/2 minus x to the 1/3. I have like terms here and here. So that gives me a negative 8x to the 1/3 power. And then I have like terms here and here, which means that it's plus 19x to the 1/2. And that's my answer. For B, I have f of x minus g of x. So parentheses, f of x is 8x to the 1/2 minus 5x to the 1/3 minus g of x, which is negative 3x to the 1/3 plus 11x to the 1/2. So for my first parentheses, those stay the same, the signs. What's positive is positive, and what's negative is negative. Now that I have a subtraction here, anything in this parentheses, the signs change. So I have a negative 3x to the third, so that means that it's going to be a plus 3x to the 1/3. And since I have a plus 11x inside the parentheses, it's going to be a minus 11x to the 1/2. So like terms here, which gives me negative 3x to the 1/2. And then like terms here, which gives me minus 2x to the 1/3. If I go down to here, we're going to do a multiplication and division operation, where here is f of x. F of x is 10x to the 2/3 multiplied by 3x to the 1/2. I got 10 times 3, that gives me 30. And then I got x, which I have the same basis of x, and then using our product powers rule, we must add our exponents. So this is basically 2/3 plus 1/2, so that gives me 7/6. For g of x divided by f of x, so that means it's going to be 3x to the 1/2 divided by 10x to the 2/3. This is going to equal, so I take 3 divided by 10 in a fraction sense, that's as low as terms it's going to get, so I'm just going to leave it as 3 divided by 10. I'm going to have x here. Now, using the quotient power for exponents, I must subtract my exponents. Now, I'm going to subtract 1/2 minus 2/3, which gives me a negative 1/6. And if I want my exponents to all be positive, I'm going to say it's going to be 3/10 x to the 1/6. Last thing that I'm going to do is perform function compositions and evaluate each values. So here f of x equals 2x plus 5, g of x equals, I'm sorry, that's the equal sign, g of x equals 2x squared, and h of x equals 3x minus 4 all divided by 2. So here I have g of x is a function of f, and I want to find what g of x is 3 with the function respect to f. So first thing I'm going to do is I want to evaluate g of 3. So that's what I'm basically doing, is I'm going to g of x, and anywhere that there's an x, I'm going to substitute it in with a 3. So I'm going to say it's 2 times 3 squared. And 3 squared equals 9. 9 times 2 equals 18. So now that I know that g of 3 equals 18, now I want to find out what f of 18 equals. So now I'm using f of x, where f of x is 2x plus 5. Anywhere there's an x there, I'm going to replace that with an 18. So I got 2 times 18 plus 5. And that would give me a value of 41. Looking at b, the first thing I'm going to do is I want to find out what f of 5 equals. So now I just got 2 times 5 plus 5, which that equals 15. So now I want to find what h of 15 is. So that is up here, so I'm just going to say 3 times 15 minus 4 equals 2. And evaluating that, that gives me 41/2. For C, I'm dealing with g, or f of 1 first, so I'm going to go f of 1 equals 2 times 1 plus 5, which that equals 7. So now I want to find what g of 7 equals, where I got 2 times 7 squared, which 7 squared is 49, times that by 2, that's 98. Last one is I have h of negative 2, which then equals 3 times negative 2 minus 4, all divided by 5. Gives me negative 6 minus 4 is negative 10 divided by 2. It gives me negative 5. I'm sorry, this should be a 2. My bad. Now I'm going to go f of negative 5, which then equals 2 times negative 5 plus 5. So this is negative 10. Negative 10 plus 5 is a negative 5. Okay. And that is performing functions and operations and compositions. Hope that helps. Until next time.